so exciting to be here. I'm Anna. As you can tell probably from my surname, I am from this country originally, but I have lived in London for the last 6 years. But this is my first time being sort of back as a developer, and it's so exciting to be here to talk to you about some React programming. I work as a developer at Hive, and we're a company who do smart homes. And there is a reason why I want to show you what we do. We do a lot of different things. We've got our whole range of smart devices, mainly thermostats, but also 4 different types of light bulbs and cameras and plugs and sensors. So you can control all of these devices with our applications, but you can also set up schedules and actions, such as if the door opens, turn on the light bulb. So we have a lot of complexity in our applications. In fact, it's such a complex application that after a year of working at that company, I still don't understand half of it. So I'm just sticking to the things that I actually know, which is usually just light bulbs. And we have 3 different apps that allow the users to control our devices. We've got the web, which is written in React. And at the moment, we still have the Android and iOS apps that are written in Swift and Android SDK. We also have quite a wide range of the sort of backend services and the actual controlling low-level apps. So we have about 6 or 7 different teams that need to cooperate. So any time someone comes and says, we would like to create a feature, it means that 7 different teams need to cooperate and develop the same thing to the same spec. And as you can imagine, that is A, long, and B, very expensive. And C, it doesn't always work out very well. And so we decided that we will introduce React to rule them all, or at least on the front end, because obviously we can't yet do backend with React, but seeing how things go, that might be the case soon. And so when you tell people, let's use JavaScript for all the things, people like me will get very excited, because I, as a JavaScript developer, I'm really happy that I can do native apps. But a lot of people get terrified, and especially native developers, and a lot of business people as well. They are wondering, what does that mean for us? Well, there are a few reasons why we decided to transition, and a huge amount of one of the biggest reasons was the fact that we can reuse code. We can take the code that we use to develop our web app and use it to create our native apps. And that means that we will reach much faster delivery. We have to write things once and not 3 times, with their limitations, obviously. That means that we have lower costs for development. But also, it's kind of easier to hire in a way, because you don't have to hire an Android dev, an iOS dev, and a React dev. You just have to hire a React dev. And last but not least, it's also a really cool thing to do, because it's one of the new shiny things to play with. And so the rest of my talk will be about our journey of how a bunch of web developers became native developers, and how we took our code from web to native. And originally, when we started working on this project, I made a few assumptions about what we can reuse and what we can't reuse. I thought that we will be able to reuse the UI components easily. I thought that styling would be impossible to reuse, because the styling in native world is so different from the styling in web. And then I assumed that business logic would not be shareable either, because there are so many things in native world that work simply differently. But I was entirely wrong. In fact, actually, it's quite the opposite. And in order to explain why that is, I would like to first talk a little bit about how React Native works, how we render components, and then sort of take it from there to explain what we're reusing and what we're not. So React Native surprised me at first, because I, as a React developer, thought I would be completely lost. But in fact, we still write the same JSX. We still use pretty much the same libraries. We're still using Redux and Redux Sagas. And all that stuff is exactly the same. The only difference is that you use views instead of divs, essentially. Well, at first, it looks like it. So you've got your app. That's React app, and it's just any old app that you could right? And that sits in a JavaScript runtime. And that's the interesting bit for me, because I originally thought it would be compiled down to native, but actually we still run JavaScript app there. And that sits in the native environment. And there is just this thin layer around the JavaScript thread that sort of translates whatever is happening in JavaScript into native and vice versa. So as I said, it's not compiled code, and it's also not just sitting in a web view, which gives us greater power to actually reach out to the native world and actually talk to hardware, etc. So what happens with components? Keeping that in mind, what happens with components? How do I get from having that JSX that I always knew to having an actual thing render in a mobile phone? Well, there is a little bit more theory behind that. When you have your JSX, what React essentially does is it passes it into a virtual tree. It's basically just like a blob of data that tells you what the state of the app is right now, what should be rendered, what kind of components there might be. And then you send this blob of data into the final destination. So usually it would be DOM, and the web browser sort of figures out how to render that, or the renderer will figure that out. And similarly, it would be very easy to send this to Android, to iOS. You can even control hardware with React these days, because the renderer allows you to take this blob of data and render it to anything. So I've kind of made an assumption, OK, so I've got JSX. The JavaScript runtime will just pass that into the tree, then React Native Bridge will take it and send it over to the native bit, just as a piece of information, and then the native thread will just render it out. And that could theoretically work, and I think there are a lot of people who are trying to do this. But the problem is that there are a lot of differences between platforms, unfortunately. When we look at the components, or like the UI kits that we get from different platforms, we see quite a few differences. So these are HTML tags. You've got your A and span and header. And you can kind of tell that this is semantics, right? On web, we really care about the difference between a span and a paragraph and H1 and headers, etc. We actually care about the information that they carry together with whatever content they have. And that is because web was originally created as a document. It's a web page. It wasn't supposed to be an application to begin with. So the whole system was created around the fact that we just want to render out some text. And later on, obviously, we added JavaScript, and we started being able to write dynamic apps, which is great. But we're still dealing with the components, and we still want to use the power of semantics and accessibility that it gives us. And when we look at iOS and Android, you will see that we've got views and scroll views and sliders and labels. And even between these two platforms, there are differences. Because, for example, iOS has date picker, which allows you to select date and time, but Android has separate components. So there are always difficulties with figuring out, well, if I write one thing, how will that render? If I write a view or a div, we know that they would probably match each other. And the same thing with paragraph and text. But when it comes to flat list or slider or H1 or header, it's not very obvious how we would render it out. Of course, we can say, well, H1 is a text with specific styling. But then I'm kind of losing the semantics of it. And if I write down text with specific styling, how will I know that it's supposed to be H1 on web? So there are difficulties with trying to figure out, how do I map it? What is what in these platforms? And so it's not surprising that React Native actually decided to have a completely separate system from web, because they are really quite different platforms. And so there are cross-platform solutions, obviously. There is the React Native Web, which is or was used by Twitter. There is the React cross-platform, which is done by Microsoft, although they're using Xamarin, so I'm not quite sure what is going on with that. And we did look at React Native Web, but unfortunately, they cover only about 60% of the native components to sort of convert React Native apps into web apps. And it's so new that, serving 1 million users, we have to make sure that our app will work properly, and we didn't really want to take that risk just yet. Having said that, there is a certain amount of components that we can reuse. In the previous talk, you saw headless components. I call them here logical components, but it's essentially the same thing where we don't render anything, we just have the logical bits around it. And we have also this kind of hacky approach, potentially, of supplying the end components that the component is supposed to render as props. So just super quickly, this is a logic component as an example of what I was talking about. It's just like a conditional feature. We have a lot of feature flags in our app. We just want to render some things only if a feature flag is on. So this component just says, well, if it should render based on some conditions, render out the children, otherwise don't render anything at all. And this we can reuse between web and React Native because we don't actually care about what it renders at the end. And then we have sort of props components. I don't know really how to call it, but we use it especially for SVGs. SVGs are amazing. It's so useful to use icons as SVGs. But unfortunately, when you look at SVG, it just looks like HTML. And there are libraries in React Native, but you have to spend some time figuring out how to convert the icons you get from your designers into something you can actually use on both platforms. And so we created these wrappers around all of our SVG icons, and then we just supply whatever element should be rendered out as a prop. And we have this handy map. This one is from our web app, where we say, well, when you see an SVG component, just render out this SVG. Similarly, we have a React Native version for this. But we decided to keep this sort of very low-key. We didn't want to use this approach a lot, because we, again, weren't very sure that it would actually work on a large scale. So that was for the components. Unfortunately, the answer is we can't really reuse them much. But there is styling, and the story there is a little bit more hopeful, optimistic. I have to tell you, the CSS is still there. No matter how far away you run away from web, CSS is following you everywhere. I actually have found out that there are people who like CSS, but I'm definitely not one of them, so I wasn't very happy about this. Having said that, CSS in React Native is quite bearable. So the normal React Native styles are a very sort of typical CSS in JS. You just define your styles as objects, and then you apply them as you would normally do in web. But there are a few differences. So first thing is that, and quite a few CSS and JS frameworks have this, you can see that things are defined in camel case and not kebab case, so it's actually not CSS really. It just looks like it. React Native doesn't have units, so you can see that font size is 30 in there because, you know, you can write PX and it's not going to do anything. And there are some other differences, such as flex is by default on all components and is by default in a column and not in a row, which is a bit confusing for web developers. So there are differences, but you can kind of see that it's heading in the similar direction. And since we're using styled components on web, it was actually really easy to take them to React Native because there is a React Native version of styled components. And that means that you can just write CSS like you would in any other place, and you can write exactly the same stuff for web and for React Native. And we have this like amazing collaboration with our designers who sort of defined variables that we can share. They defined base components so that we know how things are supposed to look in both platforms. And that also increases consistency of design between platforms if you can reuse it. And you don't have to worry anymore about like, oh, the Android app looks a little bit different. So they all now look the same because we can reuse that. Having said that, there are differences, and we have to keep that in mind. So styles are kind of somewhere in between. We can kind of reuse them, kind of not. But there is business logic, and that is actually the exciting bit for us. And again, you kind of saw it in the previous talk that there was these sort of like logical components around. And normally, we would just use connect with Redux and Redux sagas. But essentially, the idea is the same. You've got different components that you supply into it, different UIs, but the business logic can be shared. There are some bits in native apps, though, that are different. There are some hardware integrations that you can't obviously do on web, such as taking photos and stuff like that. So there are some amounts of native business logic things that we can't reuse. And then there are some native SDKs, such as for analytics, that we have to use that we can't actually take from JavaScript. Apart from that, though, since we do run our app in a JavaScript runtime, we can just use anything that is in plain JavaScript, and we don't have to worry about changing a thing about it. So our whole store, everything that we have written in Redux, actually still works fine. And equally well, the translations are completely reusable. So when we are writing now our application, we spend quite a lot of time on components and style. And that is mainly because, as I said, we can't actually reuse the UI very much. We spend some amount of time on writing business logic, but most of it is just moving the business logic that we already have for web into a place where we can share it between the two apps. So that usually just means moving it into a different folder. So that is an easy one. And very little time we spend on the actual native code. And that is given partially by the fact that we can do a lot of stuff in JavaScript, but partially also given by the fact that React Native already has a huge ecosystem of libraries that we can use. So I think we have maybe like 2 or 3 either forks or our own libraries that we wrote, but vast majority of things, including working with camera and Bluetooth, are things that we can actually use kind of out of the box, and that's really amazing. So to sum up what we can share and what we can't share, it's exactly the other way around. We can't reuse UI components. We kind of can reuse styling to a certain degree. And we can reuse practically all of our business logic, which gives us a huge boost whenever developing anything. So that's quite all right, and we're quite happy with it. But then there is a question, you know, I've been talking about like what we are sharing, but how are we actually going about it? Well, obviously you have to take the code that you want to reuse and put it somewhere where both apps can reach it. And the most obvious answer to this problem would be a monorepo, where you have one folder that is like a core or shared folder, and one would be for web, one for React Native. Some people even combine these together in one folder, so you would have a file where you have, I don't know, index.web.js and index.android.js, etc. But there is a problem with monorepos, and that is that once you make a small change, unless you have a very custom tool, like a build pipeline tool, the whole thing will get compiled. So every single time if we pushed into this repo, we would get builds for web, for Android, for iOS, and that is just really not something that we would want to do to ourselves. Because then obviously you have much longer wait times, etc. And so we decided at that point to go for multiple repos, and we were thinking about sharing the code using NPM and have some kind of versioning around it. But that proved quite cumbersome, and that's especially because NPM has a really silly way of having sort of like private packages, and that proved so complicated for us that we ended up having like a very custom tool that one of our developers built that literally checks out a branch or a hash commit from the web app and uses it in the React Native app. And although that works, there are a lot of problems, for example, with conflicts. You know, like if someone bumps up the version of the commit that we're using, then you know the conflicts in our pull requests are occurring a lot. And we're actually now thinking, once we have a little bit of time, to start using monorepos instead, because that would make it much easier. And hopefully soon there will be a build pipeline tool that can just out of the box build whatever we actually want to build. And if not, we're probably just going to write our own. So this is how we are sharing code, and although it's been a bit of a journey and a bit of a struggle, I think we're at a relatively good point, because we still have a huge advantage of being fast while not having too much hassle with the tooling. And so we have just a few more steps to take. At the moment, we haven't released our React Native apps yet, so our users are still using the native apps. But we have started doing trial runs with a lot of our users. At the moment, I think we have a trial run for about 15,000 users. And the apps look really nice. I actually find like they do look native and they feel really native. It's really nice to use them. And some of our trial users are already giving us really good feedback. For example, this was one of our first ones. It was on the first day, and they said, "I have found it much clearer than the old app." And we were like, yes, you know, that's great. And then even better was one comment that said, I don't understand why we are trialing this, because it looks pretty much like the old app, just the design changed a little bit. So users actually can't tell that the whole thing changed, that they are no longer using native apps. And that's amazing, because when we used to have web views and that kind of stuff, the apps were clunky and slow. And with our app, the users actually can't tell the difference, which is great. And using RAM bundling, even the performance of the startup of the application is exactly the same as our current native apps. So it feels like we're getting a lot of benefits out of it. And that's about it. Thank you very much for your attention. Good time? I think we've got plenty of time for questions if anyone has asked anything.
Yes, they have asked, and they have upvoted one a lot. What do you think about progressive web apps? Will they replace native apps in the future?
That's an interesting one. I really love progressive web apps. I was a huge fan of them for a very long time, but they just never really picked up. And whenever we tried to use service workers in our apps, it just caused a lot of problems to a point where we usually just decommissioned them quite quickly. And then I think it was last year at the React conference in London, Lee Byron actually from Facebook said that Facebook doesn't believe that progressive web apps will ever get the traction that they would need. And that's why Facebook invests so much money into developing native native frameworks, and React is just one of the many that they have. And obviously, I don't know what the answer is, but if a company like Facebook is investing so much money into native, I would say that's probably the way things will go.
The second question, what do your native mobile developers think about React Native?
That's a tricky question. So we obviously had native teams in our company, and we offered all of our native developers that they can join us in React Native, and some of them were really eager to do it. One of them even took Fridays off to learn React Native quickly. But a lot of people obviously have a lot of reservations, and it's understandable, especially when you look at the history, like with the web views and all this stuff, that JavaScript solutions were just never really on par with the native solutions, but it looks like React Native actually does the trick. So I'm hoping that more native developers will start seeing React Native as a good alternative and start joining us as well.
I think we have time for one more. What do you think about Flutter?
I don't know what Flutter is, I'm sorry. It's shocking.
Then there is one more that people would like to get answers on. Performing heavy operations is affecting rendering. React Native only offer one thread for JS. How do you deal with that problem?
So there are actually quite a few libraries by now. So like the main heavy things on the JS thread would be animations and possibly some like heavy native operations. To be honest, we don't have any like computation heavy things that would stop it, but especially gesture handling and animations have been problematic, and navigation actually. Those are the three main things. And by now there are really good libraries that sort of go into the native UI thread and don't block the JS thread at all. So that way JS thread is free to do whatever it needs to do while having the sort of like heavy operations on the UI thread. So I would say as long as you use the right libraries for the right job, that's not a problem anymore. Cool.
Thank you.
Thank you. I'll be around, so if you have any questions, let me know, or hit me up on Twitter, which is Blithen with double N. Cool. Thank you.
Thank you, Anna.